Okay, in this lesson we're going to look at section 3.6 and 3.7. In 3.6 we're going to look at the zeros of a quadratic function. So follow along on your handout. So when you draw a parabola, how many zeros does a quadratic function have? What are the different possibilities? Well, first you can consider the following. If you have a parabola that opens up and it sits above the x-axis, you will have no x-intercepts or zeros. Or if you have a parabola that opens down and sits under or below the x-axis, you will also have no zeros. So that's case 1. If you have a parabola that opens up and it just touches the x-axis once, or a parabola that opens down but touches the x-axis once as well, then you will end up with only 1 0. Let me fix this. And if you have a parabola opens up and crosses the x-axis, or parabola that opens down that crosses the x-axis like this, you can have up to 2 zeros with quadratics. So we can actually tell how many zeros a quadratic function has by looking at the factored form or the vertex form of the equation. Let's take a look at example 1. Find the number of zeros using the vertex relative to the x-axis. So in example A, the function f of x is given in vertex form. The vertex is located at 5 and 4. The a value 2 is positive, so that means you have a parabola that opens up. So approximately at 5 and 4, you have a parabola that looks like this. Well, how many zeros do you have? You actually only have one, or none, no zeros. Okay, so let me add this in. In example B, f of x is in vertex form again. The vertex is negative 2 and 3. A value is negative 4, so your direction of opening is down. So let's make a sketch of this graph. We have negative 2, positive 3, parabola opens down, so the sketch looks something like this. And so this time you have 2 zeros. Example C. Now, this function looks like it's in standard form, but don't forget, if you only see an x squared in the equation, you can also interpret this as a vertex form, because you have 5 times x minus 0 squared minus 8. So that means the vertex is 0 and negative 8. Direction of opening, 5 is positive, so it opens up. So your parabola will be 0, negative 8, opens up, which means that you will also have 2 zeros in this case. So in example 2, we're going to look at finding number of zeros by factoring. So for your first trinomial, you have x squared minus 3x minus 4 equals 0. Find the product and sum, you get this. And the zeros of this quadratic function then would be x equals to 4, x equals to negative 1, which gives you 2 zeros. In example B, your quadratic function has left side and right side. From yesterday's lesson, you know that in order to solve a quadratic function or find the zeros, you need to make one side equals to 0 first. So we will rearrange the equation. It turns into a trinomial. Product and sum, or patterning, tells us that this is actually a perfect square trinomial. So it turns into x minus 5 squared equals 0. which means there will be 1 0 only in this problem. In our last example, which is 4x squared plus 8x plus 5 equals 0, we will try to factor this, but the product and sum of this quadratic function will be 4 times 5, 20. The sum will be 8. So this is not factorable. So we'll try using the quadratic formula to see if there are any zeros in this quadratic function. So you take out your negative b plus or minus b squared minus 4ac divided by 2a. Substitute the values of a, b, and c. You realize that under the square root, you have 64 minus 80, which will end up as a negative number, and you cannot square root a negative number. As a result, you will not get any zeros from this quadratic function. So having seen this case, we're going to look at the possibility of finding the number of zeros in quadratic functions without doing all these long calculations. So let's take a closer look at the quadratic formula. So here it is. Can you find the number of zeros without actually solving a quadratic equation? Our very last example showed that, well, if the answer in the square root, b squared minus 4ac, is a negative number, we can tell right away that there won't be any zeros, which means that this is a very important part in the quadratic formula that will allow us to predict the number of zeros. So this part, b squared minus 4ac, is called the discriminant. And we have seen that if the discriminant is less than 0, you won't get any roots or real roots. Now what if this is equal to 0? So imagine this whole part in your quadratic formula is 0. Then x will become negative b over 2a. That only gives you one answer. So the discriminant equals 0 gives you 1 0. And last but not least, if b squared minus 4ac, the discriminant, is greater than 0, you'll have some number that you can evaluate in the quadratic formula in this part. Because it's plus or minus a number, that will give you two possibilities. Let me put this back. Okay. So now we're going to use the discriminant to figure out how many zeros we will have in the following quadratic functions. So we'll take out b squared minus 4ac, substitute 8 for b, negative 5 for a, negative 10 for c. You will have 64 minus 200. You don't even need to calculate this to know you will get a negative answer, which means that there won't be any real roots in this quadratic function. Example B, 6x minus 1 equals a negative 3x squared. Once again, this quadratic function is not written in a form so that one side is equal to 0, so you need to rearrange it first. And then you apply the values of a, b, and c in the discriminant. 36 plus 12 is what you get, which will be a positive result. Therefore, you will have two real roots or two zeros. We will look at another application of the discriminant. If a function is kx squared minus 8x plus k, and we want to find out when will this quadratic function have no zeros with the k values, well, we can just rely on this relation where b squared minus 4ac is less than 0. Substitute a, b, and c. Simplify. So negative 8 squared is 64. Negative 4k times k is negative 4k squared. You rearrange this inequality, divide both sides by 4, and square root. You will get the absolute value, Nope, it's in the wrong place. So let me correct this. Sorry about that. It should say the absolute value of k is greater than 4, or 4 is less than absolute k. Okay. A similar example, this time we are looking for exactly 1 0. So the discriminant will be 0. You follow the exact same steps and solve for k. So this is 3.6 using discriminant to find out how many zeros you'll have. On the next page, we're going to show one example, short example from section 3.7. This is the only thing that you need to worry about from this section for finding equation of a parabola, given some zeros and a point. Because you are given the zeros of a parabola and a point, naturally you will start with the factored form. So you have y equals to a times x minus your first 0, 2 plus root 3, and x minus your second 0, 2 minus root 3. Now, in order to simplify this more easily, you're going to regroup. So take out the brackets so that you have y equals to a times x minus 2 minus root 3, x minus 2 plus root 3. Because we can find the difference of squares pattern among the two trinomials here. If I group x minus 2 together and x minus 2 together, I can expand and simplify like this as a difference of squares. Square the first term minus square the second term. And then expanding x squared, or x minus 2 squared, you get x squared minus 4x plus 4. And then square root of 3 squared is negative 3. Simplify, you get y equals to a, x squared minus 4x plus 1. And now we can substitute the point 2 and 5 in order to find the a value. So simplify your work. A turns out to be 5 over negative 3. And so you can put everything together. Your equation in standard form can be found by multiplying 5 over negative 3 times x squared minus 4x plus 1. You distribute your negative 5 over 3 into the 3 terms, and here is your final answer.